Hey, welcome everyone. So, in today's session, we'll understand about Git and GitHub from scratch to an advanced level. Okay. So, as per our discussions on the roadmap, let's start with Git Basics today in our first session. Okay.
Git, right? So as you guys have already the roadmap clear, so let's get started on the Git basics first, and then no, we can move on to the advanced stuff as well. Okay. So I'll be giving a Git basics refresher plus practical setup, so that you guys can practice once the class is done. Okay.
Okay.
So a little bit of a theory where I'll explain on the Git foundation, and then we do some kind of practical session in the class itself. I'm going to do the practical sessions, but yeah, once the class is completed, you guys can follow along, and then if you come up with any kind of questions, feel free to ping in our WhatsApp group, right?
Mhm.
So, intro, think of it like Git. So, Git is kind of a distributed version control system. Okay, that means basically it allows the developers to track their changes in the code. Not only for developers, any kind of data that you are keeping in the version control system, which allows to track all your changes, right? So that is what the Git. Okay, so Git is the foundation. Okay, is the foundation of every DevOps pipelines. Okay. So if you're building any kind of pipelines, of course, Git or any kind of version control system, which is mandatory because from there you will be pulling the code and then performing remaining aspects, right? So that's why it is a foundation. So everything else like Kubernetes, Terraform, Docker depends on Git workflows. Okay. Because all of them actually pulls the code from the version control system, right? So that's why that is the foundation, right? Today, uh, we'll understand some basics related to setup. Do you guys have already a GitHub account?
Yes, I have.
Yes, Vijay, I
What
have.
about you? Okay. Okay. So today we'll understand about setting up a Git locally with SSH, creating and cloning the repos, and we will practice some commits, branches, and then merging, and then we'll do a push onto the remote as well. Okay. So if you guys already have a GitHub account, that is fine. If not, just head over to the Git download section and then basically download on your operating system. Okay. Either it can be Mac, Windows, or Linux. Once you have it, the .exe, then go ahead and install that with a kind of default settings that Git pop-ups, right? So just go ahead and execute those. And once the Git is set up, you can see Git bash on your system. Okay, so Git bash, if you type Git bash on your search, you'll be having Git bash on your system. But in my case, I have kind of a zip file where basically Git I have not downloaded a .exe file because of some restrictions on my system, but I can go ahead and use that for the use case. Okay. Software's portable Git. I have a portable Git where you can see the Git bash, right? So I can just double click on that and it will open Git bash on my system. Okay. So it's a kind of terminal where you can execute any kind of instructions here. Okay, so if I see pwd, right now I'm at root. I will move on to a folder and C drive. Okay, users, my username of the system, and then I will move on to the video section where our crash course folder is exist. Okay, so I have created a folder related to DevOps crash course. Okay, in the videos folder of the system. Okay, so now what we can do is as once the Git is already established and so ready on your system, then basically we can configure a few parameters like git config -FN global user.name. Okay, so you need to have a username and user email to be configured on the system, so that whenever you make any kind of changes or push any kind of changes on the remote system, it will detect that tie to a specific user and email. Okay, that's what the meaning of this is a one-time setup that you will be doing it. Okay. Commands like git config global user.name, that's your username. Okay, and git config global user.email, your email ID. Okay, just set this locally once on the system, and then you're ready to go and do perform any kind of operations in the Git. Okay. So now you understood the Git, the purpose of the Git, and there is a GitHub. So Git and GitHub. GitHub is kind of a cloud-based system which basically allows you to manage your repositories in a collaborated fashion. So meaning you have an options like choosing a pipelines or choosing kind of issues, or you can create a pull request. All those extended features will be available from the web interface. So understand clearly, the Git is a kind of a tool that you are using to interact with GitHub. Okay, got the idea, right?
Yes, Vijay.
So now I'm into this system and the DevOps crash course. So what I'll do is I'll make a directory. Hope you guys are aware of the basic commands, right? Day 01. Okay. If any point of time, if you guys feel any kind of questions on executing these commands, let me know. I'll explain you. mkdir is for making a directory, cd is for changing directories, and if you wanted to
Well,
move back, cd dot dot.
that
Sorry.
is fine.
Yep.
That is fine, Vijay. We
Right.
are aware.
Okay. Now I have made a folder day 01 where we will be basically go ahead and create one repository in the GitHub, and then we clone that repository into our system and make the necessary changes, and then use the other stuff. Okay, so let me initialize first the git init on this day 01. So now this folder is basically saying that it is ready, and it can kind of execute any kind of git instructions. Okay, so now let me go back to GitHub. Okay. Okay, this is my GitHub repository where I have few repositories already exist on my system, but let's go ahead and create a new repository and play around with that. Okay, so new and repository name. So I will call it as Git concepts. Okay, so Git concepts, and this description. This is all about Git and GitHub. Okay. And you can choose the visibility, like basically you can set up a private or a public repository. For now, let me go ahead and stick with the public repository, and you can add a README file which basically gives this description initially, and going forward, once you're building this project in a high level, you can update your README based on your project structure, and based on the code that you're implementing it. Okay, so let me add this README and create repository right now. Right. Now you can see that the README, we have our repository Git concepts, which has only the README file right now. This is all about Git and GitHub, right? So if you wanted to get this repository local onto our local system, we can use HTTPS, SSH, GitHub CLI. So there are different options. So let me use the HTTPS for now and copy URL to the clip code, and then we execute a command, which is git clone. Okay, git clone the repository URL. Okay.
Vijay, one question. Hello.
Yes, yeah.
Why we use a clone? What is the meaning of that
The cloning is basically you're fetching all the remote data into your local
in
system
our
so that
system?
you, yes,
Okay.
into our system so that we can make our own necessary changes into the code. Let's say, for example, there is application which built, right? And being a developer or being a DevOps engineer or the operations engineer, you want to make some changes onto the existing code base, right? So you cannot directly make onto the GitHub. Of course,
Hmm.
if you are the administrator, you can do that. But yeah, in real time, you will be cloning that repository onto your system, and then you will make necessary changes on your system and pushing back those changes onto the remote repository, so that everybody can track your changes. They can collaboratively understand, what are the changes you made. If they feel everything is good, they will merge back onto the master branch or a main branch, right?
Okay.
So cloning is just you're pulling all the changes from your remote onto your local system. Okay. So now you
Okay.
use a git clone this repository URL.
Okay. So we'll use this command into our VS Code, right?
Yes, and into
To
our
pull out the code.
into our
Hmm.
git bash, right?
Okay.
Right.
Okay. Okay.
So
Fine.
now in our DevOps crash course, we are in which folder? Let's see. We are into day 01, day 01 folder, right? Um I think change directory to D01, git init. I should initialize it here and day 01. And now I will do git clone. Okay, the repository URL. Oh, sorry. Git clone and where is that repository URL? Here is the URL. Okay. So what it does is it clones the contents which exist on the GitHub, and then you can see that Git concepts. That folder will be downloaded here. Now you can see Git concepts, right? So you go into the Git concepts folder and then uh, do some kind of stuff if you wanted, like for example readme.md, right? So if I feel I wanted to update something in this file, I will do vi on this git bash, which opens an editor mode. Then I can press I on the system keyboard, which basically allows me to insert our instructions, right? So now what I can do is updated readme. I just added some content in this file. Okay, and press escape. Now you can see on the down where I'm using colon WQ exclamation mark, which basically allows to save the contents in this file and exit. Okay, so now vi readme.md has been updated. If you want to see those changes, just do a cat on this file, which gives the content, okay, which we updated right now. Okay, so this is the data which exists on the GitHub. Now we have added our own commit or kind of change, right, into the system, updated readme. Now basically Git will track all the changes that you have made. Okay, so how does it track? Let's say you have to issue a couple of commands where to identify what kind of thing has been changed or updated. You can use git status command. Okay, now you can see that on branch main by default, right now it is a main branch because we don't have any new branches right now created. We just pulled the existing GitHub account repository which has a main branch. Okay, so now we are on the main branch, and now you can see that it has given a red color modified readme.md. Okay, so it's stating that this has been updated. Now we have to stage these changes. Okay, so what does the stage means? You add this file into an area called staging area, and then you commit those file so that the basically Git will states that this file has been committed, and then you can push to the remote origin, or mainly you can push onto the remote repository. Okay, so how do we do that? You use git add. Usually, you can mention a file name here, readme.md. But if you have hundreds of files where you made the changes and you wanted to commit all of them, you don't need to add all the file names. You just use dot symbol. Okay. So this will add the file into a staging area. Now, if you see git status again, You can see that it is modified and it is in now green color, right? So basically, previously it was in the red and identified that the changes were there, and now we added into a stage area. Once the file has been added to stage area, we commit with some message. This commit, git commit is another command with -m message. So this message is stating that what kind of changes we have made in real time. Let's say if you added some feature related to authentication, you can add, I have updated a code base related to an authentication login change, something like that. Okay, this will give you a clear-cut understanding in real time that what kind of changes has been made by whom. Okay, but in our case, we just updated readme with extra line. Okay, you got the idea, right? So in real time, we will be actually mentioning the proper commit message, okay, what you have did it. But in our case, as it's a simple project and we don't have any code-based changes, just we are updating a README. That's what the message I'm writing here, okay. Now you can see that just updated README with an extra file, one file changed and one insertions happened, right? Now we have updated the change, but just doesn't mean if you are updating it here, it will reflect in no, in the GitHub, right? So you have to push your changes from your local system, which from our Git bash onto the remote repository here. Okay. So right now, yeah, right now if you see that initial commit, this is the initial commit, which is nothing but once we create our GitHub repository, added a read file that was generated an initial commit. But our commit data should reflect in the GitHub. That means this message just updated README with extra line. This should go and update it here, right? Or add it here, so that we understand that how many commits were made and what are the changes were made and everything, right? For now, it has only one line, but we made locally changes. We will push those changes onto the remote. Okay. So how do we do that? Git push new origin main. Okay, so or you can just execute for the first time whenever you're executing it, git push -u origin main basically tells that you're setting up an upstream branch first, pushing onto the main branch. Okay, so just execute this command and which will ask you for an authentication. Okay, you can see that select a credential helper, click select manager, and then it will ask you to enter your GitHub credentials to basically log into the account and push your changes. Okay, so do you want to have a sign in with your browser or a token? Okay, so click on sign in with your browser and it will open up this one, and then you give your email ID and then provide the password for GitHub to log in. So in my case, I have a two-factor authentication enabled into Git. So I'll show you guys how do you do that. But it requires an authenticator app in your system phone, and then you can enter the code which you have received. Okay. So I'm just entering that code, which will allow me to log into the GitHub. Okay. So 715756. Right. Now you can see that I was able to enter it. Let's go back to our Git bash. Does it take any effect? Can't reach. Okay. So the best idea usually you can do is you can set up a SSH authentication mode. Okay, so every time, let's say if you wanted to push every time those changes onto the GitHub, you don't need to enter those credentials of your website or a GitHub account, right? So that's really tedious to do every time, right? So to avoid that process, what we can do is we can generate an SSH key, okay, which will create a public key and private key. We can copy that public key onto the GitHub account, and whenever you do a git push again next time, it won't ask you to enter your credentials anymore. Okay, so it won't ask you to you will not be getting that pop-up to provide your GitHub credentials, or maybe you will not, you don't need that. Okay, because The SSH authentication works in such a way that it basically authenticates behind the scene, comparing it with your public key and private key. And once the authentication is successful, it will allow you to dump your changes. Okay. So just to Control C here, and then I can do something like I can set up an SSH key onto the system, and then I will copy the same key or the public key onto the remote system, so that it establishes a kind of handshake. Once GitHub detects that, then it allows us. Okay, so how to do that? I'll do SSH keygen is a command, okay, which allows you to generate a key with -t RSA. So the type of algorithm we use for generating a SSH keygen is RSA-B 4096. So the number of bits used to generate this RSA algorithm keygen is 4096. Okay. So this is a command which we executed. It will create a key pair, okay, kind of a public and private key. Press enter now. Now you can see that generating a public or private key. Enter file in which to save the key. So let me use the default location, but if you wanted to use any kind of location, you can copy paste that location path here. That will allow you to put your private key or public key there. Okay, so in my case, I'm just pressing enter, so that it will create a folder in my user folder like .ssh id underscore RSA. Okay. Now you can see that enter passphrase for this one. So you can enter any kind of passphrase. So next time whenever you're pushing it, you have to enter that passphrase to detect it. But in our case, I'm just keeping it empty. Press enter. Again, enter same passphrase again. We have not entered anything, so I'm just again pressing enter. Now you can see that it has created a kind of an SSH key. Okay, so let me go back to the place where it has created it. Go to C drive, go to users, then my user, and you can see that .ssh folder, right? You can see id underscore RSA and id underscore RSA. Two files were generated. In this, one is a private key and one is a public key. Okay, how do you know that? Just click on this and right click on this file. Uh, Go to the properties and details. Now you can see that the name of this file is id underscore rsa.pub. Okay, so this is the public key file and the other one is private key. So take this content of the file and create a key pair or SSH key pair in a GitHub. Okay, so how do you do that? Let me first open this file for now. Okay, the file format is not supported, but let me open from Notepad. Okay. Right. So this is the key pair which got created. Our public key which has been created. I'll just copy this and paste this key into the GitHub. Okay. So right after this class, anyway, I'll be deleting this key so so that it will not be available publicly open. But for this class sake, I'm just showing you this public key. Okay. Now go back to the GitHub and go onto your settings of this root of your account. Go to the settings where you can see SSH and GPG keys, right? Click on here and there are no SSH keys associated with your account, but for now, let's go ahead and create new SSH key. Let me call it as demo key. Okay. Authentication type is key type is authentication, and then just paste that key here. Okay. Click on add SSH key. Okay. Yeah. This is security mechanism again, so which will allow me to, which will ask me the token. So I'll be entering it 797558 from my phone. Now the key has been added. Okay, so what does this now happens is whenever you make any kind of changes or commits in the future, it authenticates against your key and it won't ask you every time the password. Okay, for pushing any kind of changes. Now as we have a SSH key on our system. Clear, guys? Any questions?
No, Vijay.
Okay. Let me add this commands git add, git commit, first commit something, and git
push -u origin main asks for password. You can log in using browser as such way of pushing changes. So you use as such keygen -t rsa-b 4096 command. Copy your public key and create a sh key in GitHub UI from settings and paste the key. So now this is what we have done, and let me do one thing: git remote -v, which basically shows this is my remote, and git remote set URL origin. So I'm just stating that this is where the remote set URL, like basically saying that I'm going to push the changes onto my main branch by setting up the remote URL as set URL. Okay, this you can do one time. You don't need to do any for the remote, but you execute a command git push. Okay, so what happens? Let's see. First of all, again git status again. Now everything is clean. Git push will actually pushes the changes onto our remote. Git push origin main. Okay, main does not appear to be a Git repository, could not read from the remote. Okay, Git push set URL origin main and just issue this, what is this, our repository URL endpoint. 1 second, get the endpoint of this Git concepts, SSH way, this one. Okay, so what I'm doing is, okay, now if you do git remote -v, you can see that. If you see clearly, there is a difference from git remote -v command, which shows the origin previously using HTTPS connection. Now we have updated by issuing this command git remote set URL origin to SSH way of dealing. Okay, so previously we used HTTPS way, but now we are saying that we wanted to use SSH way, where the origin is this one, git@github.com colon this one. Okay, so let me copy this command and paste in your notes as well. And git remote -v initially shows HTTPS, but after executing set URL origin command, then it shows SSH way of URL. Okay. So once we have established that that we are pushing it to the SSH way, then we can use git push -u origin main. Now, for the first time, it will ask you to, are you sure you want to connect to the remote server? Just type yes, press enter. This will actually pushes your changes onto the remote branch. Now you can see that it writing the objects, and then if you go back and refresh this page, you will see that those changes will exist. Just updated readme with an extra line. Okay, so you can see that updated readme. Updated readme. Clear? Any kind of questions so far? We just updated the changes from our local system onto the GitHub UI. Okay,
with the process that we followed. So next time whenever you are pushing any kind of changes, let's say now we have readme.md file. I will create one file called test.py, okay, a Python file. I will write some code. Being a developer, I can write some code like print hello world. Okay, this is the code which I have changes in my test.py. If I do git status, which will track these changes. Now I will do git add command to add this file, then git commit with added test.py file for my new application something, okay, meaningful message, and then you use git push command. So now you don't need to enter the password every time, or you don't need to authenticate onto your GitHub account, because we have added an SSH key behind the scene. It does that. Okay. Now if you go back onto this remote repository, then you can see that the test.py file got added to for my new application, right? If you see this, the changes will be there inside the file. Print hello world. Okay. Clear? Any questions?
No,
Okay,
Vijay.
where you are trying to push the code, like in the master branch or
Yes, now we have pushed on to the main branch. This is master
like,
is, yes. Up to 2019, GitHub used to call the branch name as a master. Okay. After 2018 or 19, they have completely renamed it to main. Okay. So now they are calling master is nothing but equal to main. Okay. Now for now, we are pushing it to the main branch, but in real time, the practice is to create your own branch. Okay, like a feature
Mhm.
branch, and make your necessary changes on that branch, and then you merge those branches and then push those branches, or maybe you know, push your branch onto the remote system. Okay, so that is a real use case. Okay, that is what now we are going to do. Okay,
So
so
the simple workflow which I understand is you're creating a GitHub repo and you're
yes,
cloning the
repository,
repo in the local
right.
and making the changes, add, commit, push.
Right, git add commit push, and while pushing you can use SH way of pushing the changes. That means you generate a key pair, authenticate it, so that you don't need to provide every time the password and username while pushing the
Mhm.
changes. Okay, this way is in real time we use SH setup, not just using a manual passwords. Okay, so now what we can do is now we are pushed to the changes onto the main branch, right? But in real time, you will not be doing that. It is even the branch will not allow you to directly push onto the main, because all the production code will be deployed from the main. Okay, so the main branches are the master branch is useful for only the production base. Okay, not for just testing your changes. Okay, you have to create your own branches, make the changes there, right?
Okay.
So now we were going to do that. Okay, so now we have a test.py file, and one more command you can also use, git log command, which basically shows all the commits were happened on this particular main branch. Okay, if I do git log, now you can see that initially the initial commit which was created from the GitHub, this is the commit ID, and the next we have created just updated readme with an extra line. This is one more commit we made, and now later at the last we added another commit, added test.py file for my new application. So these three commits were made. You can see that this is a commit ID. These three are different commit IDs, right? So even if you go on to the Git repositories, where you can see that three commits here, right? You can see, right? Three commits, out of which these are the commit IDs. Okay, so you can basically see any of the commit. Initial commit, this commit, and then okay. You can select this any kind of commit ID and see what are the changes were happened. So you can see from here plus, which indicates a line being added onto this file. Okay, and here if you see this change, you can see that plus, that means it has been updated with the readme. Okay, so those kind of changes were added, different commits were made. Now We will understand about creating a branches. Okay, not just like pushing onto the main. We will understand about how to create a branches and work with our own branches. Always create branches for your features. Features are nothing but your own changes that you are basically creating it for your application. Let's say, as I told you, if your application is a web user interface and you are making some authentication login page, you write your code on a feature branch and then push those changes, and everybody in the team can somebody in the team can review, and then once they feel that everything the changes are good, they can merge into the main branch or a master branch. Okay, so always create branches for your feature. How do you do that? There are a few commands. Okay, git branch with branch name. Okay, this creates a branch. Branch is nothing but if you understand the concept, like tree has many branches, right? Tree has many branches. One branch will talk about login, one branch will talk about payment system, one branch will talk about customer support related code base change, right? You can have many developers basically make their own changes and merge all them into the master, right? That's how in real time it works, right? So you create using git branch name, or you can also use git checkout to a branch name. Okay, so the checkout is like switching the branch from one branch to other branch. Okay, so I can issue a command git checkout to my feature. That means I'm moving my current branch onto checkout or kind of feature branch, right? And there is other way to create a branch, git checkout hyphen b with feature one. Okay, so what it does is it creates a branch and automatically check into that branch. Check in the sense moving into that branch. Okay, then once you are onto the new branch, then you again execute these commands: git add your changes, git commit with a message updated feature branch, and then you do get add git commit, and then you can if you wanted to merge these changes, right? Or maybe you can push this branch, git push hyphen u origin the branch name, pushing the local branch to remote repository. Okay, so this is how you basically do a branching. Okay, so now if you go back onto our system, gitlog has given all the commit history and commit details, right? I missed that point to mention it here, I believe. Yeah, gitlog shows entire commit history details. Okay, but you can also execute one more command like git log hyphen hyphen one line hyphen graph. One line will basically gives a compact view of your commit history. If you just do git log, which will give you full history details with author, date, and all those stuff, but this one line will give you a compact view, okay, in a clear understanding fashion. Okay, but you can also use git log hyphen one line and then hyphen graph hyphen decorate. Okay, so this is an additional command you can use to basically see clear understanding on your changes. Okay, but yeah, graph graph. Okay, which will give you a kind of graphical representation what was happened from where, and it just gives you this kind of representation. But all of these commands are pretty much same. You can use just one command or multiple commands or one line command to track your changes or understand your commit history clearly. Okay. So far so good. Now we have two files, readme.md, test.py. Now we are into the main branch. If you see the cat test.py, we have print hello world. Now at this point of time, your manager has given a chance for you to upgrade your code base, right? Your test.py to add few more lines with your own changes for your application, right? So let's say in our case right now, the main branch has print hello world, but let's add some more new lines in our test.py and push the changes, and if everything is looks good, we can update our original main branch in the remote repository to our own code base changes, right? So what you can do is, if you are working on your future branch, right, that means you're updating the code base. That means you have to create your own feature branch in real time. There may be a scrum that they will ask you to develop your own application improvements, right? So in that case, you will create your own branch, make the necessary changes. Okay. So what I will do is, if I do now git branch, it will show me in which branch right now I'm in. There is an asterisk symbol here and main, right? So that means we are right now in the main branch. Anyway, git bash is showing here, but if it doesn't shows it, you can just execute always this command git branch, which indicates right now on which branch. If you wanted to create another branch, git branch and feature one. Okay, so I'm creating a branch called feature one. Okay, now if I do git branch again, you can see that we have two branches. One is a main branch, one is feature branch. So what does this feature branch has? It has exactly the same code base of your readme and test.py. Okay, you are just branching it from here. That means you are taking a copy of everything from main onto the feature one, and you make your own changes in the feature one, and then later you can merge onto the main. Okay, that's what the intention. Okay. Now, if I do git branch, I can see that our cursor is still in the main branch, but we have to check out to that branch. As I told you, use a command called git checkout to feature one. Okay. So what happens is we were moving our cursor or pointer from main to feature one. Okay. Now you can see that it was switched to branch feature one. Now if I execute again the command git branch, now the asterisk symbol is showing at feature one, right? So this clearly states that now we are into the branch called feature branch. Now if I do ls again, the same code base will be there because we have branched it from the main. So the same set of data will be there in the feature branch as well, right? Cat test.py. If you see that, now again we have the same file. Now as per our manager instruction, we wanted to improve the code from test.py, right? So what we can do is we'll just edit the file, and I will added a new feature related to authentication, something. Okay, in real time you will be writing the actual code. The developers will be writing the actual code and making the necessary changes. Okay, but in our case we just added a new print statement. Okay, so now we have changes in the file in the feature branch. Now if I do git status again, which git status, which will show that this file has been modified. I will do git add, I will do git commit -m, added or kind of updated test.py by adding a new feature related to authentication system, authentication, something in real time necessary commit, you will be adding it. Okay, now you can see that the changes were there still. If I go back to the main branch, this change will not be there. Okay, if I wanted to go back to the main, how can I do that? I can do by using git checkout to the main. Okay, So now you can see that now we are into the main branch. If I do ls cat test.py, you can see that our test.py still has previous changes because whatever we are doing, the changes we added, that was on the feature branch, not on the main branch, right? So the main branch is still exist with the same code base, but we are working on our main branch, feature branch with our different changes. Okay, so I will again check out to the feature branch. Okay, and see cat test.py print hello world, and we have our own new line, right? So what we can do is we can say that okay, in a collaborated fashion in the real time, you will be pushing this branch onto the GitHub. Okay, so you're not actually merging locally and pushing it. You don't need that, but you can also do. And now what I will do is I will push this branch onto the remote. Okay, so git push -u origin branch name. So I'm saying that setting an upstream branch. So the -u you don't need always for the first time whenever you're pushing a branch. You use feature one with an -u, but next time whenever you make some changes on the feature one branch, just execute git push will work. Okay. Only for the first time you can set up as an upstream. Okay. If you don't do that, just if I do git push,
What is
right?
hyphen U actually? What is hyphen U?
It sets the upstream. So basically
Means
saying, so it's basically saying that the same kind of replication that you are doing from your feature branch, like right now we have a local branch name called feature one, right? You're setting
Mhm.
the upstream branch same as feature one in the remote as well. That means in the GitHub, it will create a branch name called feature one with the same name. Okay. So git push hyphen set upstream. So which will create with a branch name called feature one, which is same as your local branch. Okay, this is only for the first time you have to do it. And next time, once you make any changes, you just do git push. You don't need to set up the upstream every time. Okay, so hyphen set upstream you can execute like this, or you can also issue a shortcut notation which is like -u. Instead of writing all this setup stream, I just used -u. Okay, so git push -u origin feature one. Okay, this is the first time as we are replicating these changes of from local to the remote. So I'm setting that as an upstream, and then I will do. Yeah, now you can see that the changes has been pushed onto the feature one. Now if I go back into the Git concepts, our test.py file, do you think anything is updated? No, because we have not pushed the changes onto the main branch. We have pushed the changes onto our own branch called feature branch. Now you can see that there is a pop-up here. Feature one had recent pushes 16 seconds ago. Okay, so if I click there, or maybe I can select here, you can see now I have two branches. One is main, one is feature. Okay, if you feel that, so this is where the pull request comes in. So once you create a branch, then you can go ahead and create a pull request. Okay, so click on compare and pull request. What it does is it will notifies your team members these are the changes you made. Now you can see the notation here. You're comparing your feature one and pushing those changes onto the main branch. Okay, so you're just saying that I'm creating a pull request. Please everybody in the team to just review the code that I have made, and if feels everything is good, then go ahead and merge it to the master or a main branch. If you feel that there is a problem in the code, they will issue another comment. Based on the comments, you will be again following up on the thread. Okay. Now you can say that add a title. Yeah, this is the title which already has description. If you want to have any description, let's say I have made necessary changes for authentication. So you're saying that you're creating a pull request now, but while creating a pull request, always add some assignees. Okay, so to for the reviewers, okay, who can basically review your code, right? So in our case, as I am the one who right now working, but in real time, there will be a team of people where working with you, right? So you can assign to your senior folks who can review your code. So in my case, I have assigned to myself. Click on create pull request. Okay. So what happens is it's not merged right now. Okay, even if you go back to the main test.py, the changes were not merged onto the main branch. We just created a request, pull request. You can see here, pull request is one. Okay, so there is a one pull request which got created, and if you click on that, already the member who got assigned, right, he gets notified when there is a pull request, and he will open that and he will see what are the commit he has made, right? Somebody has made. So we'll just open this. So this is the commit. This is the one which is there in the main branch, and this is the one the developer has worked and made some changes. Okay, so I have the you can see that what kind of files got changed. There is a test.py file got changed from this to added a new line. Okay, if I feel that everything is looks good. Okay, so this is good. Let's go ahead and merge this kind of changes into our main, which will not break our production code, right? So if you feel that everything is good, just click on merge pull request. Okay. So it will create a commit message stating merge pull request from this person to feature branch. Okay. Just confirm the merge. So now once the merge has been happened and completed, now if you go back to our main repository, now you can see the test.py got updated by adding a new feature. That is the latest commit, right? So the same commit message was there. And if you open that, now the changes were there. Okay, so that's how you basically write or create your own feature branches and make necessary changes, and then create a pull request. Now you don't have any pull requests, see that, because we already merged onto the main branch. Okay, any questions so far? Because I'm just executing the commands. I know you guys feel a little bit nervous if you don't practice this later, but any questions as of now?
No, Vijay.
Right. So we have created our own feature branch. We merged onto the master, right? Now what I can do is I can go back, even I can go back onto the feature branch right now on from the Git bash. Right. I will check out back to the main, and I can do something like git merge. Okay. So always execute a merge command from your main branch onto your feature branch. Okay. So you're saying that the changes were there, all the changes were there in a feature branch. I'm merging onto the main branch. Okay. So if feature one. So what it happens is local. Now we have merged it from the GitHub, but now locally the changes were not merged, right? So now by you executing the command git merge, it merged the changes from the feature branch onto the local branch, okay, onto the main branch, okay. So now if I do cat test.py, you can see that these changes were already exist, okay. Even I can do git pull also, which will pull the changes from remote system onto my local system. Git pull origin main or git pull, okay. You can see that it is pulling the changes, okay. Now if I do git pull again, yeah, it is already everything is up to date, okay. Yes, status, no changes. Right now my main branch is currently has all the details. Git log. If I do that, now you can see that this was the latest commit which we made. Before that, this was another commit, and then test.py. The from all the commit data, you will see everything here in the git log. Okay. Now we have our feature branch still sitting. Now we already pushed the changes onto the GitHub. We created a pull request. We merged back onto the main. Looks good. Everything is fine. That our task is completed, right? So we don't want it that particular branch exist on our local system, right? We don't want that branch. We already done with our changes. We can just go ahead and delete that branch. Git branch -d feature one. Okay. So now our branch has been deleted locally from our system. Now if I do git branch, you can see I have only main branch. I don't have feature branch, right? Because once we are done with our task, we can remove that branch. Okay, but that doesn't mean that it has been removed from the GitHub repository. Okay, we have removed it locally, but still our feature one branches exist in our GitHub. So to make a clean slate in the GitHub as well, we can do a command git branch push -d feature 1. Yeah, feature 1 has been deleted. Usually what we'll do is before even executing this command, git branch -d feature 1, we can actually delete from our remote first, and then we can delete it locally. Okay, instead of deleting it first here and then trying to execute the push command, which will fail eventually, right? Because we already deleted locally, you can't execute the same command to delete it from remote repository, right? So if you're the administrator, you can go ahead and delete it, the branches from branch settings. But what I can do is I can issue git checkout -b feature 1, the same branch which I'm creating it and checking out. And now if I do git branch again, now we are into the feature branch. Now I will do git checkout to the main branch. So now I'm just replicating the same kind of stuff. Okay, you got the idea, right? Hello.
Yes, Vijay.
So I'm replicating the same kind of feature branch just to delete it first from the remote and then delete it locally. So git push origin delete feature 1. Okay, so I will be deleting that. Once that is deleted, then I can do git branch -d feature 1. Okay, so I'm executing two commands. You can branch spelling, I have messed it. Yeah, so I'm executing two commands here. Git branch -d1, this is -d feature 1, this is a local way of deleting a branch, and this is a command which allows to delete a remote branch. That means in the GitHub. Okay, so I'll paste it here. Delete a branch from GitHub. Issue this command. Delete a branch locally from system. Issue command git push git branch -d the branch name. Okay, so these are the two different commands. You're using git push origin delete feature 1, which will delete eventually from the GitHub. This is from the local system. Okay, now if I go back to the version control system and just refresh my page and see that I don't have any feature 1
Only
branch.
one,
Yes,
only main branch is there.
yes, that's how we create the branches. We merge the of course, yeah, I have missed one command. Once you check out to main branch, you can issue a merge command to merge feature branch changes to main branch locally. For merging changes on GitHub remotely, you always create pull request, and once approved, we can merge. Okay, so you cannot directly merge from the GitHub. You always create a pull request, and your team will review it, and then they can merge it. And but locally, you can use a command like git merge branch name. This is the
Oh,
one which basically allows you to merge it locally. Okay, this is the local merging process. This is the remote merging process.
Vijay, can you explain in the simple terms the second last statement?
Yes,
Once you check out to main branch, yes, this is confusing for me.
yeah, once you check out to main branch, that means let's say you already working on your feature branch, right? once all the changes were done and once you committed, if you feel that you wanted to merge these changes onto your local main branch, first you need to check out to that main branch using command git checkout main. Okay,
Hmm.
git checkout main. And once you are onto the main branch, then you can issue a command like git merge the branch name. Branch name in our case is feature branch,
Feature one.
right?
Mm.
Whatever it is, yeah, the branch name.
Okay.
So this way it will merge the local changes only locally. This is not happening in the remote. If you wanted to do the merging process remotely, you're doing it using creating a pull request. Clear?
Yes.
Any questions so far? Because this is all covers related to branching, merging, pushing the changes, creating all those stuff. So now there are some tips like you can use while no tips. Always create feature branches, avoid direct commits to main or master. Okay, of course we won't be calling master anymore. We'll be calling main branch. Okay, always write meaningful commit messages. Okay, so these are the two tips you have to follow. Always create feature branches because whenever you are working on your changes, create your own feature branches and then avoid direct commits to the main. And also of course you have to write a meaningful commit message so that if somebody sees your commit, they don't really need to read hundreds of lines of code. Okay, just reading your commit message itself, they will understand what the change you made. Just if I say I have made some changes on this feature, that doesn't make any sense. But if I make some commit like I have made the necessary changes related to authentication system, then if somebody is seeing that commit message, they will understand, oh, you worked on authentication system code base change. Okay, using that they will understand clearly what kind of changes you made. Okay, so this is for today's session. I will be giving a couple of tasks for you. Okay, so you need to do uh, if you already have it, set up Git with SSH. Okay, so on your own machine, set up a Git with SSH access. I don't want you to execute authenticated password every time while using Git push. And then you create a new repo and push initial commit, and then create a feature branch, add files. You don't need to add only one file. You can add many files, commit them, and then merge back to main locally as well as remotely by creating pull requests. And then share your repo links in class group. Okay, so this is your task. You set up your SSH connection, create a new repository and push some commits. You create a feature branch, add some files, commit them, merge back locally as well as merge by creating a pull request, approve yourself and then merge into the master and see those changes. Finally, you share your repo links in the class group so that I'll understand your practice and what kind of changes you made on your remote repositories. Make sure that remote repositories are public, not private. Okay, guys, any questions?
Mm.
So with this,
Vijay,
yes, yeah.
yes, please go on. Please go on.
Yeah, with this we are done a basic understanding about Git as a refresher. It's not the advanced concepts we understood now. These are all the pretty much important, of course. But in tomorrow's session, we'll be we'll be getting deep dive onto the, Git, some of the advanced concepts. Okay, like we'll understand some more concepts as we discussed in the roadmap. Okay, but
Mhm.
whatever the steps that you have executed, everything, every day, the developers will be doing it behind the scene. Okay, not only developers, being an operations engineer, you check in your code related to infrastructure, your Terraform code or your Kubernetes manifest files. All those changes will be there in your remote repositories. Okay, but in order to do that, you have to follow all this process. Okay, so you remember these commands in your brain, like git add, commit, push, pull, merge, and all
Mm.
those. You should be in your brain. Okay, clear? Any questions?
Okay. Vijay, so for clone and fork, these are similar things.
Yeah, that's what I'll be covering in tomorrow's session. Fork is just you will not be having an access to the original repository because you are not the owner. You are forking someone's repository onto your system, and you make your necessary changes and improvements and push onto your repository. So forking is nothing but just you're taking a copy of someone's repository onto your GitHub repository. Okay, let's say.
Okay,
Uh,
that is not cloning.
Cloning is you're basically pulling your changes local into your local system, but forking is you're not pulling it onto your local system, you're forking it onto your repositories list. Now you can see that I have 55 repositories,
Mm.
right? So if I feel that I like someone's code, you can see project end-to-end Terraform. I have forked it from this, no, this particular
This is repository.
product, right?
Mm.
So
Someone else
yes, someone else has been
repository.
written some code base, and if I feel that I wanted to extend, or improve his code base, I will fork his repository, and I will work on my own changes and push it here. Okay, so this way,
Mhm.
I will have a complete set of code of theirs onto my system. Okay, that is fork. Okay,
Okay.
we can do a fork on your
Okay.
repository. So once you can also do a fork on my Git concepts now. Okay, just once you log in, then you use basically go to my repository, and then you can fork that particular repository onto your system. Okay, which will give you the
Okay.
same kind of
Okay.
data. Okay, any
Okay.
questions?
Which is second thing? Yes. Which is second thing? The roadmap you have provided. So, what would be the build tool here? Is there anything similar like Maven or Gradle?
No, we are not using Maven or Gradle. Yeah, of course, you can
Okay.
enhance your knowledge while deploying Java-based applications or anything like that. But yeah, of course, we
Okay.
use Docker to build our applications. Okay, for now. But yeah, you can extend, Maven or .NET related applications. Then you can use some related, build tools. Yeah,
Okay.
right. Any more questions?
No, Vijay, I'm clear.
Okay, okay. Cool. Then with this, we will wind up the basic fundamentals on Git, and then we will see in tomorrow's session a little more advanced concepts. Okay. Thank you.
Okay.
Thank you.